Okay, 9.3C. So here we have a study done in hotel rooms, and they placed signs in the room, and they tried to get people to reuse their towels and to save on washing machine costs and water. And these are the results. So we want to know, was there an effect on whether or not the towels were reused? So we're just going to focus on reused. And this is one of the chi-squared tests where we're going to assume that everything is even. So I need to find the percentage of the total. So 1372 divided by 3190, and I get 43%. So this right here is 0.43. So the null is going to be H naught says that pi sub n is equal to pi sub s, which is equal to pi sub c, and so on. We're testing to see if all of those percentages are the same. So now we need to compute the expected values for each. So I'm going to multiply all of those by 0.43. Nope, sorry. I meant all of these by 0.43. So 610, oh boy. 610 times 0.43, and then 612 times 0.43, and 668 times 0.43, and 620 times 0.43, and I'm going to run out of room. Oh no, I'm good. 680 times 0.43. Okay. And then I do the subtractions for each. So I'm going to compute the chi-squared statistic. Watch how fast I can do this. Not often I have the answer sheet finished. Okay. So here are the subtractions for the chi-squared. So we end up with 4.98 and 5.73 and 0.02 and 0.58 and 0.17, and I add all those together and I get a chi-squared term of 11.48. So then I take that 11.48 and I plug it into here. How many degrees of freedom are there? 4 there, because there are 5 categories. And 11 point, what was it? 11.48. And that gives me a p-value of 2%. So, going back to the first set, what is your conclusion? Was there a difference in towel use? So I didn't even write the alternative hypothesis. So the null hypothesis said all the categories are equal. The alternative would say at least one category is not equal. So we get a p-value of 2%. Do we accept the null or reject the null? Reject the null, what does that mean? At least one of them is not the same. So is there a difference in towel reusage? Yes, there is. And there are lots of different ways to say that, but the explanation is going to mean the same thing. Okay. So here, we have an assumed percentage, the national average. 20% of people sleep in the dark, 50% of people sleep with a nightlight, and 30% of people sleep in a lit room. How many of you sleep in the dark? Okay. Yeah, that's really weird. Like when I saw this, who knows? I thought those numbers were way high. So I am going to write my null hypothesis. So the null says that pi of darkness is equal to 0.3 and pi of nightlight is equal to 0.5 and pi of light is 0.3. And then the alternative is going to be at least one of those percentages is not correct. Oh, shoot, that says towel reuse. I'm sorry. So what are the expected values? So we're going to take 0.2 and times it by 137. So 0.2 times 137. And then 0.5 times 137. And then 0.3 times 137. So my expected values are 27.4, 68.5, and 41.1. Okay, and then you're going to do a chi-squared test. Let's say that our chi-squared term is 0.13. Now that's not what it is. What would we do with 0.13? If our p-value is 13%, do we accept or reject? We accept the null, and we would say that there is significant evidence to suggest that our numbers meet the national average. If your p-value is less than 5%, then you would reject and you'd say there is significant evidence that they are not the same. Something like that. All right. Should be pretty simple. Get to work.